So here we're being asked to write this expression without factorials. To do that, we need to be able to expand it out and cancel out common expansion parts. The problem is that n factorial and n plus 1 factorial, we don't know exactly how many terms to write. But we can do this. N plus 1 factorial can be written as n plus 1 times n minus 1, etc. In fact, we can just write this as the rest of this as n factorial. So these are equivalent expressions, this n plus 1 factorial and n plus 1 times n factorial. They are the same expression, so therefore, when we write the denominator, n factorial, those denominators, this term and this term can cancel out, so it simplifies to just n plus 1. For b, we can do the same thing. We can write this as n factorial. N plus 2 factorial can be rewritten as n plus 2 times n plus 1 times n minus 1, etc. But the rest of that can be written as n factorial. So again, the n plus 2 factorial and this expression are exactly the same. And what that leaves us is with our common terms. All the n factorial terms will cancel with, in the numerator, will cancel with all the n factorial terms in the denominator. And we end up with the expression 1 over n plus 2, n plus 1. So we can use the same idea to solve for these variables. So when we have 5 NPR is equal to 20, we can rewrite this with factorials, and we can write it like this: 5 factorial over 5 minus r factorial, and that's equal to 20. Now, this problem we're going to have to guess and check, because basically, this is a descending multiplication that we're going to get to 20. Now, if we try to simplify this expression, the problem with this is the denominator, because we don't know what r is, we don't know where to start with that denominator. However, since we know we're starting with 5, we know that we're going to start with 5, and we're going to just multiply in descending order till we get 20. So 5 times 4 equals 20. That means that r must equal 2, because we only have 2 terms that we're multiplying. So this is a guess and check strategy, and this is what we have to do for this particular problem. For b, when we set up the factorial, we end up with n factorial over 3 terms, so it's going to be n times n minus 1 times n, oops, sorry, I made a mistake there. So this is going to be n minus 3 factorial, or sorry, n plus 3 factorial. Oh, no, so it's going to be n minus 3. That's our formula. Factorial equals 336. So we end up with n times n minus 1 times n minus 2 times n minus 3 factorial. And then we can cancel out the n minus 3 factorial in the denominator. And that leaves us with this cubic function equaling 336. Now, this is a cubic function, so it is hard to solve, but we can solve this. But since these are discrete terms, it's probably easier to just guess and check. Okay, so we can just guess the first 3 terms starting with some value of n. So if I just randomly guess, not randomly, but if I were to guess an n of 3 numbers starting at some number, descending multiplication equals 336, maybe 7 would be a good option. So I go 7 times 6 times 5, and I get 210. I know it has to be bigger, so I go 8 times 7 times 6. I get 336. So by guessing and checking, I get n equals 8. Okay, by using some educated guess, we can come up with a solution fairly easily because n must be a whole number. Therefore, there's not too many numbers that we need to test to guess and check this solution. The other option would be to solve the cubic equation, which would be much harder.